MCP, or Model Context Protocol, allows you to hook an LLM up to tools. This means you can use a language model to easily control tasks or actions within things like Stripe or GitHub, or even to navigate a browser and perform actions there. Now, MCP is a bit tricky to understand, which is why I'm making this video. I'll explain how it works in detail, each of the layers involved. I'll explain then how to use it through Cursor, through Windsurf, which are coding agents. I'll explain how to use it through Claude's Desktop App, through OpenAI's agents, and then also to use it in a custom way with your own LLM setup. I'll also show you how to inspect the wide variety of tools that are out there, how to look at one in detail and see exactly the information that it will give you and actions it will allow you to take. So here's the overview, which is pretty much just what I said. I'll explain what is MCP, how does it work, the problem that it solves, how to inspect an MCP tool service like, say, a GitHub tool or a Stripe tool. Then I'll go through in detail how to use MCP with Cursor. I could really have picked any of these clients that integrate with MCP, but Cursor works well. So I'll show you browser navigation. I'll show you how to control access to GitHub repos, how to get information from Stripe, and then also how to run MCP in a remote fashion. And I'll describe why you can run MCP remotely versus just run it locally. Then I'll go through the setup for other popular clients, Windsurf, Claude App, the desktop app, OpenAI agents, and then even how to integrate with a custom LLM. So any LLM you could choose, could be Gemini, could be a model from Hugging Face. And I'll do that using LiteLLM, which allows you to wrap all APIs that serve language models. What is MCP? There are probably a lot of descriptions. My description is it's a protocol for providing services to LLMs. Now, you could say it's a protocol for providing tools, sharing the information about tools and actioning tools. But actually, MCP allows for support beyond tools. It allows also for resources and prompts. I don't really see a lot of people use these two things, but that's why technically it's a protocol that goes beyond just supporting tools, although in practice, it's pretty much used for tools. It can also provide, what's a resource? It can provide information, say, from documents. So think of having this MCP server, and it's got the information on tools, but it's also got maybe some long documents you can query, or it may even have some prompt that you can query and might find useful for running your LLM. But it turns out most of all MCPs are used for tools. So in practice, they kind of end up being a tool service. Now, there are two ways to run an MCP service. You can run it locally or you can run it remotely. What does that mean? Well, if you have a tool service, this is again providing information on the tools available for GitHub and actioning those tools, actually making the changes to the repos. That tool can be run on your computer and interface through effectively command line, standard in out, or you can also run the service on a remote server. So you could think about having it on somebody else's computer or a computer you rent and interacting with that in a server client way. So MCP can be run either in a server way, which is through server sent events, or it can be run generally locally through basically the command line, which is standard in out. Now, here's how it works. Here's how the protocol works specifically for a tool service. You have your large language model and you have your MCP tool service. The tool service will store information on that tool. Let's say it's again the GitHub tool. So it will store the list of API endpoints, the list of tool calls that can be made, and it will provide that information so it can be injected into context for your LLM. So now your LLM knows that these tools exist because it's gotten that info from the tool service. You can ask a question, add Ronan to this GitHub repo, and the LLM will make a tool call. And now the tool call will go to MCP tool service, and that's where it'll be actioned. So Ronan will be added to the repo, and then there'll be a response saying Ronan was added to the repo, and that will go back to the LLM into the tool response bucket of the context window, and then the LLM will continue chatting. So MCP is the protocol for writing this here. And when I say writing this here, I mean it's the protocol for how you store the tool information, and it's the protocol for how you initiate calls and you send responses. So that's the service. Now, if you look at it in a little bit more detail, imagine this is the LLM context. So this is the long string of text you feed to the LLM. You'll start off usually maybe with a system message, but then you have the tool information, which is coming from MCP. Then you'll have a user message saying add Ronan to the repo. The tool call is made by the LLM, and that tool call gets sent to MCP. It's actioned, and the tool response comes back, and it's injected here. And then there would typically be an assistant message generated by the LLM. So that's another detailed show. Now, why not just have a list of tools? This is one of the most common questions in MCP, and the answer is, well, you can, and probably in a lot of cases, it's simpler just to have a list of tools rather than setting up this independent tool service here. You could literally just store the tool information like this. You could store it in some JSON over here inside your code where you're running the LLM. You could also store the Python code to action the tools somewhere over here in the repo that's calling the LLM. But MCP provides a standard for how you store this info and run the actions. And because it's a standard, and because now a lot of people have adopted this standard for packaging up the services, it means there are many MCP services available, like for GitHub, Stripe, and they're all packaged in a consistent way, which makes it easier to plug and play. So that's the argument for it. Now, can I easily hook up an LLM to MCP? So for those of you who are familiar with function calling or tool calling, if you want to set up a tool, let's say for a weather service, you need to define the tool. You need to put that information, which is typically JSON, into the context. So you pass it into the LLM. And then when you call the LLM and it says it wants the weather, it's going to respond with a structured JSON object typically. That's going to be the tool call. And that tool call then needs to be extracted by you from the response and then used in order to get the weather from, say, the weather.com API. And then you take the weather.com API's response and put that back into the language model. And that's how it works with tools, and people are somewhat familiar with that. I mean, if you've done tool calling. So the question is that how MCP works? And well, it is how it works. You need to manage the flow of information to call MCP and then take back the info. But you do need to build that integration. So can I easily hook up an LLM to MCP? The short answer is not easily. You need to write the code in order to do that interface. Now, there are platforms, or I don't know what to call them. There are clients that already have these integrations done, namely Cursor, Windsurf, Claude AI, Desktop App, OpenAI agents. These all support MCP, and so the integration is a lot easier. It's basically adding in a few lines. But if you want to do it from scratch, you basically need to build this interface because the tool call info is provided in a certain format. I think it's ZOD, and that needs to be converted into whatever format your LLM expects. And likewise, your LLM provides a certain output format for tool calls, but that needs to be converted into the format MCP expects. So it's not like there's seamless plug and play between MCP and whatever you're operating your LLM with. It does require integration. It's all done if you use one of these. But if you're going to do it yourself, you need to write the custom code in order to integrate, which I will show you, and I'll show you how to do it using LiteLLM, which will wrap any LLM. But then I'll write the code that allows me to pass through the tool info, the tool calls, and the tool response here. So next, I'm going to show you how to inspect some of these tool services. For example, a GitHub service or a LinkedIn service or a Stripe service. I'll also show you a browser navigation service, which allows you to get an LLM to navigate through a browser. And then I'll start to show you how to use MCP with Cursor for specific use cases. So I'll talk about browser navigation. There are some kind of subtle things that do or don't work right now with MCP. I'll talk about how to do GitHub for granting access, Stripe, and I'll show you how to run a remote server. So all of these I'll run using a standard in-out approach, which means information is being passed locally. The server is essentially running on my laptop. But I'll also show you, I'll simulate then how you would set one up remotely with a remote server. Then I'll show you the setup for Windsurf, for Claude, for OpenAI agents, and I'll show you that custom code needed to integrate MCP with any arbitrary LLM. The scripts I'll be working with are all within the advanced inference repo, which among many other things now contains the scripts on model context protocol setup in terms of integration, but also setup in terms of walking through some of these different MCP services that I find to be particularly useful. Now, if you're not in a position to buy access to advanced inference, I'll try and describe everything so you can put in a little time yourself and replicate it, maybe with the help of a coding tool like Cursor. I'm over now in Cursor and I've cloned the advanced inference repo. the scripts here are in MCP. So I've just gone to MCP and then to the README file. And the first thing I'm going to do is explain how to inspect one of these services. So let's say you're interested in integrating a browser MCP. You want to be able to navigate a browser and you want to inspect how, say, the Playwright tool works. You can go online and you Google Playwright MCP. Let's do that. Playwright MCP. And sorry, it's actually directly opened up because I clicked down to the GitHub, but this is where I want to go anyway. So you'll find Microsoft has got this MCP service that is ready to go online. And once you find it, you should be able to, and once you find the MCP, what you'd like to know is, well, what is the list of tools that this MCP provides and what are the actions I can take with the tool? So the way you do that is using an MCP inspector. Well, one of the ways you can do it is using MCP inspector, which you can run simply with npx. Now you do need to install npm. So if you haven't got npm installed in your system, go ahead and do that. But I'm going to run now npx model context protocol /inspector, and it should open up a service. Here it's on port, it's on localhost 5173, and you have this nice UI where you're able to check, you're able to inspect some of these different servers. Now, to check a server, or to check a service rather, you need to have the right argument for kicking off the service. And you'll find that argument usually in the repo for the MCP server. So here, you'll often find some kind of example config, and it's broken down into multiple lines. But essentially, the command to start this service is npx, followed by playwright MCP at latest. So I've got here npx, and then I've just pasted this in. Now, this is an extra tag I'll talk about later, but I just want to run the basic playwright MCP, which is for browser navigation. And normally you would add in some environment variables if that's needed. If you need to configure, I'll show you that later. But for now, I'm just going to connect to MCP. And yeah, it looks like we're up and running. So you'll remember that MCP services technically can support not just tools, but also resources. And it looks like there's some kind of basic resource here, but I'm mostly interested in the tools. So I'm going to list the tools. And here I can see that this MCP server provides these different options. So browser navigate, browser go back, go forward, choose file, browser snapshot, click, hover, and type. All right, so let's try this out. And this is the nice thing about the inspector. You can actually check how it works and what the actions are before having to write it into an LLM. So let's go to trellis.com. And I've run the tool. Now I'm just going to move this to the side. And you can see it's actually opened up a browser because we're running in the default mode, which will show you the browser. And yeah, that's basically why you can see the browser. If you do not want the browser to be present, what you do is you put in headless here. Headless means the browser would be run in the background, so you wouldn't see it follow. So let's now see if we can do something else. Let's do browser snapshot. And what browser snapshot does is it takes a snapshot of the accessibility pattern of the page. Accessibility is a simply described version of the page that can be used to describe the page. For example, to people, if they can't see, they could instead listen to the accessibility pattern, for example. But this is useful for LLMs because it gives you a structure of the page that is deterministic. You can see it describes all the headings. And actually, this is quite a good way to navigate. If you provide an LLM with a snapshot of a page, it makes it quite easy for the LLM to correctly identify which buttons to push and to deterministically describe them rather than having to tell you to point on a certain pixel and click, which is possible with another version of this Playwright MCP I'll show you just in a moment. So broadly speaking, if I run this here, I'm running using the accessibility patterns of each page, and I'm able to run all of these various commands. Now I can also save as PDF, so I can save a copy of the page, and it looks like it's been saved to this folder here on my system. Now, something else I want to say about Playwright is that it can operate using a vision tag. So here, if I put in vision, instead, you'll see that the tools are going to be a little bit different. So I'm going to connect now. In fact, sometimes I find I need to refresh the inspector. So let's put this in and try to connect and list the tools. And if you remember, this said snapshot before, which was the accessibility snapshot, whereas now it's a screenshot. And that means that when you add the vision tag, it's going to instead use visual tools by, literally looking at images. And it will also allow you to click things based on XY coordinates. So I'll just quickly navigate again, https trellis.com. Let's run the tool. And let's then try to take a screenshot. Okay, and you can see that the screenshot has actually been taken here. Now, something to know about browser tools is that generally using vision features with LLMs is very imperfect. And this is something that the big labs are interested in with computer use, but it's quite challenging to have a robust pipeline and to have a robust agent that just uses XY pixels and uses vision to navigate. So if you want to navigate, using the accessibility graph can be very effective. And that's why I like running this MCP without the vision tag, so that it relies solely on the structured information. Now, this does not then allow you to get feedback on, say, how UIs look, because the accessibility info will not contain colors. It will not contain style type information or just errors in rendering. So it's definitely powerful being able to see images. But if you want to navigate, it can be more robust to not use the vision tag. So this is the inspector, and I've just shown you how to use this for a browser example. I'm going to move on now and show you how to use MCP within Cursor. So we'll actively call the MCP service using lines, using text input to our LLM. Next, I'm going to show you how to set up MCP using Cursor. So I've opened up Cursor and I'm going to go to my settings. So I'll click Cursor Settings, and then I'll go to Cursor Settings. Next, I'll scroll down or move my cursor down to MCP, and you'll see a list of the different services I have enabled. If you want to add a new service, you can either click on the Edit button, which will bring you to the file, or click this Add New Service here. Either way, it will bring you to this mcp.json file, where you'll need to paste in the commands for starting up the servers. And when you paste in a command like this, Cursor is basically handling everything else. So it's starting up the server, and then it's connecting to the server, and it's using the server. So it's building the whole interface between the LLM in order to get the tools it needs, put them in the model context, make the calls, make the tool calls to the server, and then get back the responses from the server as well. So I'm going to show you how to work with a few different servers here. And the ones I want to work with are Playwright, as I've shown you, Playwright Vision, which is where we have the vision tool allowed. I'll quickly show you Puppeteer. Puppeteer is also browser navigation. It's basically like the Playwright Vision MCP. Then I'll show you Github, where I'll give you an example of how to add or remove users from the repo. Note that this is actually a Trellis custom server, so I've modified the official GitHub release to also support adding users and removing users from repos. This is useful for me personally, because if I have errors in kind of access granting, I have automations when people buy access to, say, advanced inference. But if there are errors and I need to change permissions, I can now do it through Cursor or through any of the other platforms because I'm using MCP. And then the last one I'll show you is Stripe. Now you'll notice that the start commands are slightly different. They're usually involving npx and then passing in kind of an address, which is basically pointed to the MCP service, usually on GitHub. There can be some custom commands like tools all for Stripe will make sure to include all the tools. And then some of these servers will require you to put in, some of these services require an API key. So here for Stripe, you need to provide a secret key. For GitHub, you need to put in a personal access token. If you need a personal access token for GitHub, by the way, you need to go to your GitHub page and you need to go to your personal settings. So if I continue here, I'll go to settings. And then within settings, you need to go to developer settings and then personal access tokens. And then you need to create a fine-grained token. So here, for example, you click on generate a new token and you need to authorize, here I need to authorize using my two-factor login, but then make sure that you provide authorization for the repos that you want to provide access to. So basically you take all of this here, you press copy and you move over to here and you paste it in, and then make sure to replace any of the API keys you need, and then you should be ready to go. So now when I go to cursor settings, you can see I've got many of these turned on. I'm just going to deal with one at a time. If you put in a ton of tools, that can overwhelm the LLM, although Claude is quite good at handling a lot of tools. So right now I'm just going to enable the Playwright tool, and we're going to have a look at interacting with that using cursor. So I'm going to close the browser, which I had open from the inspector, and I'm going to now start a chat and say, navigate to trellis.com and tell me what the text is for the largest heading. So here it's only got access to one server, so it should make use of Playwright. And you can see it's asking for my approval. So I'll run the tool. It's opened up the browser here. And actually, when it navigates to a site, it automatically gets back the accessibility pattern. So it's immediately probably able to tell what the largest heading is, but it's taking a snapshot to confirm this. The snapshot does not take in any inputs. It's just a snapshot, and then it confirms. So that's pretty good. Let's now move to look at Playwright Vision. Okay, so here's the first thing that you might not know initially, which is that Playwright Vision, or actually Puppeteer taking screenshots, will not currently work with Cursor. It will not currently work with Windsurf. It will not work with Claude Desktop. And that's because any of these screenshots, they return images. And there currently is not a way to pass an image in a tool response. So when you dig under the hood, you're not able to pass the screenshot back. Actually, Cursor will take the screenshot, but you will then just get an error. So for example, here, if I've got Vision and I say navigate to trellis.com, and I'm using the Vision version of Playwright, and it has navigated to trellis.com, which is good. And now it's going to take a screenshot and it's going to fail. Yeah, because it's returning an image and that image type is not supported. So you can try then using Puppeteer. Basically, Puppeteer is the same as the Vision approach. If we enable Puppeteer here, it should show us the list of tools available, but it's also allowing you to browse, and it's allowing you to navigate and then take screenshots as required. So Puppeteer looks like it should be enabled. I'll refresh the server here. And yeah, we've got Puppeteer navigate, screenshot, click, fill, select, hover, evaluate. And it will just run into the same problems as Vision, which I expect will be solved by Cursor and Windsurf fairly soon. But I will show you how to navigate using screenshots. It's a very useful tool because it means if you generate a UI using code, you can immediately see if the UI is broken, or the agent can, and then it can fix itself based on image-based feedback. So that's why the Vision tool is really useful, and it'll be really nice when it is supported within Cursor and within Windsurf. Now, the next tool I'll show you here is Github, and this is to allow you to provide access. So let's start off a new chat here, and I'm going to say there's a repo actually that I have. It's a private repo, and it's called, say there's a repo, sorry, I'll increase my screen size, called Trellis Research Consulting. And I'll say, let's add, and I'm going to add a dummy account that I have as a user. Now I have to have provided permission for adding to this repo in advance using my personal access token. And let's see, it's going to try clone here first. Maybe I haven't got the GitHub. Yeah, it's enabled, but it's actually not running. So yeah, now I've got it running. And you can see it's got a wide range of tools, including add collaborator and remove collaborator. So let's just copy this again. I click, how do I stop? Stop. And send that again. So here it's calling the service. It's adding the owner, the repo, the username, and then it's run the tool. And it's successfully added this user, and I'll get an email in the background. Now I can say remove that user, and it should just do everything in reverse. So you can see if I needed to add or remove a user from many repos, like I've got 5 main repos that I sell access to for Trellis. There's the advanced inference one today. There's also vision, transcription, which is audio, fine tuning, evals. And yeah, here I can just remove access. So this is a very fast way. Instead of me having to work through all the UI of GitHub to add or remove with auth, I can just add or remove permissions in this way here. Now, the last example I want to show of an MCP service is Stripe. So I'm going to enable the Stripe MCP service. And yeah, by the way, these are both available from just the Model Context Protocol page on GitHub. So if you go to, sorry, I'm clicking on the wrong thing. If you go to model context, it's model-context protocol on GitHub, you'll find underneath this organization, actually, you'll find servers, which is a little bit misleading as a word because technically they're services. They don't have to be servers. And under this, you'll find a wide variety of servers. So you can see here, there's GitHub, there's Slack, there's Redis, there's very many services. I think I'm running the Puppeteer one. I'm running the GitHub one, although I'm actually running the Trellis version of GitHub, so you can add, remove access. And then I'm running the Stripe one here, I think is present too, although Stripe is hosted by Stripe itself from there. Actually, that MCP is not the official Stripe one. And the official Stripe one is here, actually. And it should show you how to set up the config with npx. So this is the one here I'm using. And by the way, you should be very careful with which services you're using. That's why it's good to use one that's from Stripe because it's reputable. Maybe the other one was very good too, by the way. I just haven't investigated. But do be careful which services you're using because if they have malicious code within them, they could be sending information to places that you don't expect. So I've got Stripe enabled now. I'll just refresh the tools to see a list. And you can see a variety. This is definitely only a subset of the possible actions from Stripe. So you could consider increasing the possible actions by expanding on that, like I did for GitHub. But I'm just going to say, what am I going to say here? Find the last purchase made in Stripe. And I've put in the API key, by the way, so that it's able to access my account. And it's listing the last payment intent. And here, yeah, I've basically got a customer number and an ID. So if I have a system where I'm providing access to customers based on Stripe, I'm able to use the Stripe tool and GitHub. I can say, oh, find me the last purchase by this email. It'll find it. And then I can maybe identify whether it's due to have access to certain repos. And then I can use the GitHub tool in order to grant access or to remove access accordingly. So that's the Stripe MCP service integration. Now, before I move to show you Windsurf and the other ways to support MCP, I just want to show you how to run as a server instead of running as a standard I/O service. Here, it makes sense to run as standard I/O. It just means that the MCP service is running locally on my computer. But in principle, you might have a service from somebody else and you want to connect with their service. Or you may have a service that's, say, on a rented computer, but you want to connect locally. So in that case, you want to run the MCP server. Rather than running it just locally, you want to run it as an actual server. And it's very easy to do that. Any of the services I talked about earlier, like Playwright, Puppeteer, GitHub, or Stripe, you can just run them as a server by passing a port. So for example, if I want to run the Playwright server, I can pass port 301. And now my server is up and running. And I can take this client configuration, just copy paste it. It's pointing to Playwright at this address. Go to my cursor settings, edit my cursor file. So I'm just going to replace all of this with the Playwright server address. Now, of course, I'm just running the server locally, but the server could be run on some kind of remote computer. And now let's just check navigate. I should not be passing my MCP. Navigate I should also refresh my servers and I should enable the server and refresh the list of tools. So you can see it's connecting successfully to this server that's running. And I'm going to navigate to trellis.com, please. And so it's calling the tool and it's got an error here. Let's just try it once more, but sometimes I just need to restart cursor to get it to work. Yeah, so let me just close cursor, quit, open up again. Let's make some space and send. And actually, it's not going to work because, yeah, my server's not running. So let's go back and find that README, start the server, connect, and now let's try. And it's going to navigate. Before we let it do that, let's run that tool. And yeah, it's navigating. So you can see everything is working here. And this is how you run MCP in a server sent event type approach rather than using a standard in and out type approach. And next up, I'm going to show you how to use MCP with other clients. So I've shown you Cursor. It's very similar for Windsurf. I'll show you Claude. I'll show you how to do it then with OpenAI agents and also with custom code. So we'll come back to my Cursor instance to show you the code for these. But first, I'll show you Windsurf and then Claude app. Now I'll show you how to use MCP through Windsurf, Claude Desktop App, OpenAI agents, and then using any custom LLM, which is going to require a bit of custom coding. Now, here's how you use MCP with Windsurf. It's very similar to Cursor. In some ways, it's actually easier because Windsurf will show the available MCPs just below the chat box here on the right. So when you open up Windsurf, you can click right in and configure MCP. And here you can see I've already added in the correct setup for Playwright. And notice I'm not passing the vision flag, so it's going to operate using accessibility screenshots. And if you check out MCP in the README here, you can choose to add in any other number of servers that I previously showed you on Cursor. Don't forget to put in your API keys if you're using Github or Stripe. So you'll copy this here for whatever service, and then you put it into the correct file right here. So now within Windsurf, I'm going to say navigate to trellis.com. And I think it will not ask for approval, although you can probably set it up so that it does. So it's automatically just navigated to trellis.com, and it's got the information that we need. Now, just a reminder, I said this for Cursor already, but it's not possible to use screenshots currently within Windsurf either, because the screenshot is not handled correctly by tool responses. So Windsurf and Cursor, and I think Claude Desktop, need to upgrade their integrations with MCP in order to be able to give feedback to the agent here on what it's seeing from the screenshot screens. So that's Windsurf. And here's how to use MCP with Claude Desktop. You can download Claude Desktop. You can use it for free. I think there's a limit on the Claude Sonnet calls, and then it moves you to Claude Haiku. And you can add in MCP servers or services as follows. Go to Claude, then go to Developer, and then click on Edit Config. And when you click on Edit Config, it's going to bring you to a window, which you currently can't see, but it's going to bring you to a window where you can click on the desktop config, and you need to just paste in your configurations right here. So I'm going to paste in one for GitHub. I've included you can't see it here, but I've included my personal access token for GitHub. And this should allow me to add and remove users from GitHub because I'm using the Trellis MCP GitHub service. So with that done, I'm going to save, and I'm going to go back to Claude. I'll close down Claude here. So I've got to actually exit, quit, and then I'm going to open up Claude again. And this time around, if I go up to Claude and settings and I go to developer settings, you'll see that any of the services I've added are presented here. Now, I won't click advanced options because it will show my API key, but you do need to have included an API key if using GitHub. And of course, you can include any other of the MCP configurations. So if you go back out and if you go to the README within advanced inference, so just go back to the README here, you can include any of these servers here, like say Playwright with Vision, Puppeteer. You can include a Stripe service here. You'll need an API key. So all of those can be included. Now, something on Claude Desktop, if you don't pay, which I currently don't pay, it's going to limit your context length, and that's going to limit how many tools you can use. So you can see here with just one server, I've got 28 tools. I tried putting in even 2 servers, and I think roughly at around 30 tools, it just wasn't allowing me to put that many in context. Now, this probably isn't an issue if you're on a paid plan, but it is an issue and definitely limits the amount of tools and servers that you can use, services you can use if you're on a free plan. So here, let's use Claude Sonnet, and please add user Ronan ARAIG, this is just the test GitHub account I have, to a GitHub repo. And the GitHub repo, which I've provided access to via my personal access token, is Trellis Research. And I just have a consulting repo. So let's run this. And Claude will say, yeah. And Claude will also ask for my approval, which I'll allow once. And yeah, Claude has now successfully added this user with read only. So this is a really nice interface. And if I was paying for the Pro plan, I'd be able to use more tools. I'd be able to completely manage my GitHub flows, also maybe get information on who has made payments through Stripe, and kind of manage both in a pretty quick and seamless way with the help of the LLM. So that brings us through Windsurf and Claude app. The last two are a little more custom, and that's using MCP with OpenAI agents, which has just recently been supported, and then using MCP with any LLM, which is really cool because now you can actually use images. So you can use the screenshots as feedback from Puppeteer. So we'll take a look at that. Next, I'll show you how to use MCP with OpenAI agents. This is something that has just become supported. And essentially, you are able to set up a server that is using, it's not quite a server, it's using standard in-out. And you are passing in this set of commands that look very familiar if you looked at the other parts of this video on setting up a cursor Windsurf. Essentially, there's a command to start up the MCP service. And once that service is started up, agents is then able to take in this MCP server standard IO and make use of it as an argument, essentially, that's being passed in to an agent. So here you can see an agent that has got, in this case, two different servers that are being passed in, and the tools are then available to this OpenAI agent. So let's take a look at this. I've provided some quick guidance here, basically copied over from the OpenAI docs, but then I've provided a more detailed script where we can run an actual agent and have it use Playwright in order to do some kind of prompt. So you can just pass in the prompt here as an argument when you're running the script. So we'll take a look at this demo script for running OpenAI agents. First thing we're going to do is set up the API key. And I've put the API key in a .env file that's in the LiteLLM MCP folder, which we'll be using later for using LiteLLM. And then we define an agent, which is defined by a name, some general instructions. This is not the actual command or prompt. Then the server that we're going to pass in, and then the model that we're going to use. And actually, I do not want to use GPT-4. I'm going to use GPT-4o. And then we're going to run the agent, and we're going to pass in a specific prompt in order to run that agent, and we'll print out the response. So this is a pretty simple example of running a Playwright browser, allowing rather an agent access to the Playwright browser. We're going to install the requirements. There's just two OpenAI agents and then python.env, so we can get the environment variable. So I'll just run this here from the MCP folder, increase my screen a bit, install the requirements, and now I'll run this command here. And I'm just asking Python, I'm asking to navigate to, let's say navigate to trellis.com again and take a screenshot. So here, the agent should just be doing this in the background. So we're not going to see the browser pop up. We're also not going to see any approval steps. There may be a way to turn on approvals, but yeah, it seems like there's been an issue in navigating to trellis.com. Let's see, maybe if we just try go to python.org. Sure, if there's an issue there. Okay, I'm facing some issues here with running with Playwright. So let's maybe try one of the other servers, just as a live example of trying to deal with reality. So I'm going to copy this Puppeteer command here, which also is being run with NPX. And I'm going to paste it in here. Take out this headless. Actually, I'm going to just put in the command as recommended. And instead of Playwright, let's just replace that everywhere with Puppeteer and save. And let's see now, it's still called Playwright as a script, but let's see if it works any better. So yeah, this time it has opened up the browser and it looks like it's navigated. And is it taking a screenshot? Yeah, it looks like it has created a screenshot. And is it capable of returning that screenshot to OpenAI? I'm not actually sure, but we can follow the traces here on the OpenAI platform. And for some reason, the traces are not showing up for reasons I don't fully understand. And yeah, actually, I don't know why, but when I just went to traces directly, it is showing up the browser Puppeteer example. And it's showing all of my steps. And here it's showing the screenshot. And it looks like it has returned the image. And the image is in, I think, base 64. So in principle, the image is definitely there. I'm not sure if the image is being passed into the agent, but what we can do is modify our prompt. So we can say, and take a screenshot and describe the color and shape of the logo. So here it should go through the steps, and we will find out if it's able to actually see anything. And it has opened up a new browser, by the way, and it then closed it down. And let's see what it says. So it says the logo features a green hue. So yeah, it seems like OpenAI's Agents API is also not currently passing images back as a tool response. So unfortunately, any of the tools like using Puppeteer with the vision capability, it's just not able to work right now with OpenAI's agents. We will see how to fix that by taking a LiteLLM based approach, which I'll show you in a moment. But first, let's just look at some of those other logs, the traces here that failed. I don't understand why they failed, but we can take a look here. So browser navigate. Yeah. Yeah, it may be because it's trying to use the browser on my laptop and there was another browser open potentially. So I have a feeling that if I modify this back and I go and I do want to use GPT-4o. Let's just do that navigation again. There's no screenshot. Well, take a screenshot. Let's see, am I using the Playwright MCP? Let's see which server I'm using now. I'm using headless. Let's actually not use headless so I can see what happens. And let's use vision. So I've got vision here. Let's try and start this up. And okay, it's worked. So I think the reason it didn't work in the first place is because I hadn't closed down some of my browsers and there was some conflict. And yeah, it's taken a screenshot, although I don't think it's able to see that screenshot, unfortunately. So that's a quick overview of the Agents API using MCP. Now, the last demo I want to show is using MCP with a custom LLM. This means using MCP with Gemini or DeepSeek. Anything that has tool calling, even a model off of Hugging Face, should work for this implementation. And to keep it generic, so you don't need to custom code for each API style, we're going to use LiteLLM, which is a wrapper that will support many different APIs under a single unified API type schema. Now, I've made a video before about LiteLLM, so if you want a full primer, you can take a look at how that works. It's a great way to build apps because it means you're not locked into a given API provider. But here we're going to leverage that unified API and tool calling in order to link LiteLLM with MCP. And maybe it's easy if I show you here. Maybe it's easy if I show you the link itself. Essentially what we're doing is we're taking our knowledge of the MCP protocol and the list of services we want to support. And we're building this interface here that connects the LLM with this protocol here for a given service. So we need to handle a few things. We need to handle how the information on the tools comes from the servers into the tool info part of the context. We need to convert the tool call into a format the MCP protocol expects. And then we need to pass the tool response back in here. And something special we're going to do is we're going to support image responses. So if the tool responds with a screenshot, we're going to pass that into the LLM's context so the LLM can see that image. And this is really interesting because it means you can get the LLM to try and create a UI, for example, look at the UI and then get feedback on how that's performing. So for this, we're going to work out of MCP, then LiteLLM MCP. And there's a specific README file here. And there are a few installations we're going to run through before setting up the configuration and running the service. Now, I've set up this library so that it works in a very analogous way to setting up Cursor or setting up, say, Windsurf or setting up Claude Desktop. and it involves configuring a config.json file. That's going to be your critical file that is going to contain the list of all the servers you want to support. So I've put in all the servers I want to support here, including the environment variables I need. So if you're going to include something like GitHub, you need to put in a personal access token. If you're going to support Stripe, you need to put in a Stripe access token there. You'll also need to have environment variables set. So you can run this using any LLM. The ones I'm going to test are Gemini. I'm going to also test Anthropic and OpenAI. And to test any of those, you need to make sure you set your API key within the .env folder. You can check out a .env.example here. This is for setting a Gemini key. So we've got the API key to connect to the LLM. We've got the servers, or rather the services for MCP defined. I've defined the GitHub one. I've defined Playwright with Vision. And we're going to use Vision so we can get the image response. And now I'm going to write the scripts that connects the MCP with the LLM itself. And that script is contained within agent.py. So we'll take a look here at what's happening. We're importing the environment variable here, Gemini in this case, and we're setting up an agent class. So this is going to be a command line agent. It's going to operate in my terminal below. It's going to have a model that's defined. As a default, it's going to be Gemini 2.0 Flash. We're going to load the configuration file, which will load the MCP servers. And then we're going to make sure to start the servers. So we have a function here that starts a given server. And of course, we're going to want to run that for all of the servers. So we want to make sure all of the servers are up and running. And when I say servers, sorry, I keep saying that, but really this is standard in and out based service because it's running on my local client. I'm not running these as servers, although I could if I wanted to run them on a remote. The setup would be a little bit different then, because then I'd be hitting server endpoints rather than standard in-out. So in addition to having a function here for starting an MCP server, there are some other functions I want to have that are custom. One is to save an image. So if I get back a screenshot, I want to save it as base64 and return the file path. I want a function to list the MCP tools. This is important because I need to pass in the list to the LLM. At the start of the context, it needs to know what tools are available. So that's why I have this function here. Then I need to convert the tools to LiteLLM. So when I get a list of tools from MCP by calling each of the servers, that needs to be translated into a format that my LLM expects. That's what this is doing here. And I'm setting everything to be in the same format that LiteLLM expects that's defined in the LiteLLM API. It's actually in OpenAI style. LiteLLM follows OpenAI, but then it translates everything else. So you just have to write everything for OpenAI, but you can run any model like Gemini or Claude. So here I'm converting the tools into the LiteLLM format. And I also need to have a function here to convert convert the tool call to MCP. So one direction is I have the list of tools, needs to go to LiteLLM. The other direction is I make a tool call, needs to go to MCP. And then the third one is I get a tool call result and it needs to go back to LiteLLM. So this is converting things back, the result to LiteLLM. Now, the next part that we need to handle is the tool response, which is complicated a bit by the fact that we want to support images. So typically when you make a tool call, you have a tool call message, you get a tool response, and you put in a tool response message that is text. And that's actually what LiteLLM and a lot of APIs will expect. And then you'll get a new assistant response that effectively uses the information in the tool response. But here we've an image that could come back in the tool response. And so to hack around this, what I need to do is provide a normal tool response that just has text, but then I need to tack on an additional assistant message that's essentially just a placeholder saying, now show me the image, and then a user message that actually passes the image so that the model is actually able to see the image that gets passed through from the tool response. So I'll show you how that works here in handle tool response. And it's done by essentially having an image pending when we get that initial tool response. So when we handle the screenshot, we're going to save the screenshot and we'll print that the screenshot was saved and we'll store that. But at the same time, we're going to set this pending screenshot attribute here. And this is going to basically set a flag to say that okay, we got a response, but it's also got an image in it, and we're going to have to handle that after the tool response. So the tool response we send back is very simple. It's just text. It says screenshot captured successfully. But if you look down further at how that is handled, what you'll see is here, when we get a tool result from the handle tool response function, we're going to append the tool result, but we're going to check then if there's a pending screenshot. And if there is a pending screenshot, we're going to append an assistant message that says, I've captured a screenshot. Can you show it to me? And then we're going to append, here's the screenshot that was captured. And this is a user message that actually passes in the image. So the image is now going to be within the context of the language model. And this means the language model is actually going to see the image before it responds with the next assistant message. Okay, the easiest way to see this working is to walk it through. So let's open up the terminal and make sure that I've installed my requirements. So up here, I've got pip install requirements. I do need to move into the LiteLLM MCP folder. And here I'm going to, I have set my Gemini API key in the .env, and I've set my configuration in the config.json. And now I'm ready to run. So let's run here. Actually, we'll just run with a default model, which is going to be Gemini Flash. Actually, I can run just like this here. So it's got the Playwright tool. I've printed out debug logs here just to see exactly what tools are available. It's also got the GitHub tool. And I'm going to say navigate to trellis.com, then take a screenshot and let me know the color and style of the logo. So I'll allow this tool call. It's going to navigate, which is what we want. You can see I've also got this approval mechanism built in. Now it's going to take a screenshot, which I'll approve as well. The screenshot is being saved, and the assistant has reviewed the screenshot, and it looks like it's a stylized line drawing, a stylized letter T, and the text Trellis Research, and the center of the logo is a light blue. The style is simple and modern, which is correct. So it is actually seeing the image. It wouldn't be able to know that just by reading through, say, the accessibility portion of the document. So this is what tells me that it's correctly reading the image. Now, likewise, I can say remove a user. So I could say remove this test account I have from Trellis Research Consulting on GitHub. And we can see if that will work. And yeah, actually, I'm not sure if I've provided the config for GitHub. I can check here exactly what I've added in. Okay, so I've gone on here and I've actually tried to use GitHub, and initially my requests are failing, and I thought I hadn't connected the server, but it turns out the language model does have access to the GitHub repo requests. And when I prompted more strongly, saying, yes, I've several tools, it is actually able to make that call. And when I say yes, it looks like it's removed the collaborator. So my explanation there is that Gemini 2.0 Flash is not able to handle this many tools and just seems to be having an issue. Now, you can run this agent as well using any other LLM. You need to follow the LiteLLM format for specifying the LLM. So here, if I want to pass a model like, say, GPT-4o Mini, I can run the server, or run the agent rather, with GPT-4o Mini, and say again, navigate to trellis.com. Take a screenshot and report back with a logo description. So here we're going to allow the call. Let's open up the browser, which looks good. And it's going to make a screenshot. So it saved the screenshot here. And yeah, the logo is a light blue. So even GPT-4o Mini worked very well with that. And if you want, you could use Claude. So instead of passing in GPT-4o Mini, you can put in model and you want to type in Anthropic. And then you could pass in Claude 3-5 Haiku latest. And you should be able to chat with Claude. So let's see this time, let's say add Ronan to Trellis Research on GitHub. And let's see if that works. So we're testing Haiku, and yeah, Haiku seems to be able to manage this many tool calls. So it probably makes sense because Haiku's probably been trained in a similar way to Sonnet. So there you have it, how to interact using a custom LLM. And basically I've set up the agents so that you can now just add in your config in the same way as you would for setting up Cursor, Windsurf, or Claude Desktop. But you have the flexibility not just of using any LLM with this agent, but you can also use images and get feedback from images. So for example, you could build a UI. You could then have the LLM inspect the UI by browsing a given page and then adjust its code according to the performance or according to how good the UI looks. And that is everything on MCP so far. Let me know if you have any questions below in the comments, and you can find the materials both in the description where I've put some links and over at trellis.com/advanced inference.